So here I have I think this is a figure from Forsyth and Ponce, maybe it's from Sliski. I hope their lawyers aren't watching, it's somebody. And basically it talks about how you can transform an image. And so on the bottom left-hand corner you have a square, and you can see you could just translate it. They call it Euclidean, but that's just a rigid transformation where you have the rotation translation. You have similarity, affine, and projective. And we're going to talk about each of those in terms of the mathematics. So let's take the simplest example. So the simplest example here is translation. So we have an x, and by the way, in this cool little figure, sort of the original x and y is the green box. And we take our x and we just add some translation vector to it. And we saw that it was an easy way to describe this using homogeneous coordinates, where we just do x, y, and 1. We add a 1 to the end, and then we can just have a transformation matrix here, which is just made up of an identity plus the translation vector that we had from over here. And to keep the whole thing in homogeneous coordinates, we would just say, we would make instead of a 2 by 3, we would make this a 3 by 3, so that 0 vector now is on the bottom row, and what we would do is we get from one homogeneous vector to another. Okay? So that would be translation. By the way, because these are now just matrix multiplications, we could chain these transformations.